Hi guys, welcome to Know Math. My name is Sir Bench Antonio, and in this video we will discuss arithmetic and geometric sequences and their graphs. This lesson is intended for high school mathematics, especially for grade 10 students. If you are not yet subscribed on my channel, do not forget to hit like and subscribe for more of my videos and for you to get notified once I uploaded my new video. In this lesson, we will be able to determine the differences between the arithmetic sequence and the geometric sequence by comparison. So we have here a table of comparisons that we have here these basic comparisons that we will going to do between the arithmetic and the geometric sequences. Let's start with the process. The process of getting the next term of the given sequence is to have its constant number. In arithmetic sequence, we do add or subtract a constant number. And that constant number is what we call common difference. And we denote this as D for its symbol. But in geometric sequence, the process that we do for us to get the next term of the given geometric sequence is we multiply or we divide a constant number. And what do you call by that constant number? It is also called a constant multiplier. That constant multiplier is called the common ratio. And we have the symbol R for the common ratio. And that is the pattern of those sequences. And this common difference and common ratio, we can see this in their formulas. The formula of the arithmetic sequence is a sub n for the last term is equal to the first term plus the number of terms minus 1 multiplied by their common difference. And for the geometric sequence, we have a sub n is equal to a sub 1 times their common ratio raised to n minus 1. Take note that n minus 1 is an exponent. How about their graph? The graph for arithmetic sequence is a linear graph. We will form a line once we graph an arithmetic sequence. And for a geometric sequence, it becomes exponential. So the graph for a geometric sequence is an exponential graph. So let us do first determine these following sequences if the given sequence is an arithmetic sequence or a geometric sequence. Let us have a symbol A if it is an arithmetic sequence, and let's go with G if it is a geometric sequence. Number 1, negative 4 followed by negative 2 followed by negative 4, and then negative 8, negative 16, and so on. So by observation, we are multiplying by 2 in each of every term. Therefore, if we are multiplying, then the sequence is a geometric sequence. That their common ratio is 2. Right? Number 2, 65, 60, 55, 50, 45, and so on. By observing, we are subtracting 5 on each of every term. Then we have this common difference of negative 5. And that we are subtracting, therefore, the sequence for number 2 is an arithmetic sequence. Number 3, 8 followed by 13, and then 18, 23, and 28, and so on, that we are adding 5 in each term. Then, since we are adding, it is an arithmetic sequence. And so as we have here this common difference of 5. Number 4, 1, 15, 225, 3,375 that we are multiplying each of every term by 15. So we have the common ratio of 15. As we are multiplying, it is a geometric sequence. Number 5, negative 40, negative 25, negative 10, positive 5. Notice that we are adding 5 or adding 15, in each of every term. Then we have this common difference as we are adding, which is positive 15. Therefore, the sequence is an arithmetic sequence. Number 6, we have 6, 12, 18, 24, and so on that we are adding 6 in each of every term, that we have this common difference of 6, and this is an arithmetic sequence. For number 7, 160 followed by 80, 40, 20, and so on. Notice that we are dividing by 2. Then if we are dividing, the common ratio will become a fraction. What is the fraction for dividing by 2? And that is 1/2. As we are dividing, the sequence is a geometric sequence. Number 8, 2, 14, 98, 686 that we are multiplying by 7 in each of every terms. So therefore, we have the common ratio of 7 as we are multiplying. Sorry, this is 7. As we are multiplying, then this is geometric sequence. Number 9, 6, 11, 16, and so on. We are adding 5. Then we have the common difference of 5. As we are adding, it is an arithmetic sequence. Number 10, 7, negative 21, 63, negative 189, that we are multiplying by 3, but not just 3. We are multiplying by negative 3. So therefore, common ratio of negative 3. And this is a geometric sequence. In geometric sequence, you will observe that if the signs of each terms is an alternating signs, then therefore your common ratio is a negative. Take note of that. So let us now proceed to how to graph an arithmetic sequence and geometric sequence. Take note, in the Cartesian plane, we have this x-axis. Let us have this x and y axis, right? For you to know that the horizontal line is the x-axis and the vertical line is the y-axis. Let us have this example 1. Negative 2, negative 4, negative 8, negative 16, and so on. That by observation, we are multiplying by 2. As we are multiplying by 2, it is a geometric sequence. Take note that, as we have said, the graph of geometric sequence is an exponential graph. So how are we going to do that? For us to have graph, of course, we should have these coordinates, the values of x and y. For you to get the value of x on the given sequence, it is the number of terms. And for you to get the value of y, it is your terms that has been given on the given sequence. So let's say if your n value is 1, then therefore we have a sub 1. And what is our a sub 1? That is negative 2. This is our a sub 1. So if you're going to graph, the x value is 1, let's say this is 1, and the y value is negative 2. So this is our first point. Next, if your n value is 2, therefore we should have a sub 2. And what is our a sub 2? A sub 2 is negative 4. So if your n value is 2, that will be your x, and your a sub 2 is negative 4, that will be our y. And let us graph, or let us find the point negative 2 or positive 2, negative 4. This is your positive 2, and this is your negative 4. Therefore, this is your point. But what about if the n is 3? What will be your a sub n? If n is 3, we have a sub 3. So therefore, we have negative 8 as our a sub n. So this is your x value of 3, and we have here 8 for the y value. Then how about 4? If x is equal to 4, or if n is equal to 4, we have a sub 4. And what is that a sub 4? That is negative 16. So we have here negative 16. Okay. So if we are to continue the graph, we will observe that the line falls down. It is not a straight line, but it is an exponential graph. Let us try to do number 2 for us to compare the difference between the two graphs. The number 2 has its common difference of 2 because we are adding 2 on each of every term. So we have the difference of 2. Therefore, it is an arithmetic sequence. And take note that arithmetic sequence has the graph of a linear graph. So let us find the x and y values of each of every term. Again, your x value should be the n value, and your y value is your term. So if your n value is 1, we should have a sub 1. Your a sub 1 is also 1. So therefore, if we have here x value as positive 1, and we have this y value of also positive 1, then this is our first point. But what about if your n is 2? That we have a sub 2. And your a sub 2 is 3. So we have here 2 for your x value and 3 for your y value. Then this is our point. Next one. If your n is 3, therefore your a sub 3 is 5. Then we have 3 for the x, 5 for the y, this one. And if your n is 4, we have a sub 4 of 7. Then we have 7 for the y value. So therefore, this is now your point. And observe that it is a straight line. Although it is not as straight as you are expecting, but it is a straight line. But if you are to compare it to number 1, number 1 is an exponential graph, and number 2 is a linear graph. Let us try more example. Example 3. 4, 1, negative 2, negative 5, and so on. Observe that we are subtracting 3. As we are subtracting 3, it is an arithmetic sequence, and your common difference is negative 3. Let us find the value of x and y coordinates. that n will be your x and your term will be your y. So, if your n is 1, your first term is 4. So, where's that? This is your x and y. So, your first term is 1 is your x and 4 is your y. This one. Next, if your n is 2, then we have a sub 2 of 1. Then this is your x value, this is your y value, so therefore, this is your next point. If your n is 3, that your a sub 3 is negative 2. So this is your x value of 3 and negative 2 of y. And lastly, if your x is, or if your n value is 4, then your a sub 4 is negative 5. So we have here now the next point. So let us observe that, I'm sorry, let us do a straight line. Oh my god, again. A straight line it is. Okay. And there. It is a linear graph as it is an arithmetic sequence. How about number 4? Let us try to check that each of every term we are multiplying by 2. That we are multiplying, therefore, it is a geometric sequence. And what is the graph of geometric sequence? An exponential graph that show x and y values. We have n and your term. If your n is 1, we have the first term or a sub 1 of 1. Where's that? Here. If your n is 2, we have the a sub 2 of 2. And where is that? Here. If we have n of 3, we have a sub 3. And that is 4. Excuse me. And this is the one. If we have n of 4, then we have a sub 4 of 8. This is 4, and this is 8, and there it is. So observe that it is not a straight line, as it is an exponential graph. And those are the difference between the two graphs. The graph of arithmetic sequence, which is a linear graph, and the graph of geometric sequence, which is an exponential graph. And that is all for the comparisons between the arithmetic sequence and the geometric sequence. Please do not forget to hit like and subscribe for more of my videos, and thank you for watching.